and welcome to lecture 5.8. We're going to be using applications of our zero factor property. So let's take a look at how we can work with the zero factor property with number problems. For example, the product of two consecutive odd integers is 63. Find the integers. So the product of two consecutive odd integers would be an x and an x plus 2, because we need to skip one. So I don't know what my first one is, so I'm just going to call it x. But my second consecutive odd integer is going to be x plus 2. The product of those two numbers is 63. So it's going to be x times x plus 2 equals 63. I'm going to distribute the x squared plus 2x equals 63. To use our zero factor property, I need everything on the left-hand side, or at least I need everything on one side, and set it equal to 0. So I'm going to subtract 63 from both sides, getting x squared plus 2x minus 63 equals 0. Let's factor the left-hand side. Two numbers that multiply to negative 63 but add to positive 2. Well, let's see. 3 and 12 won't do it. 63 and 1, of course, won't do it. What about 9 and 7? If I take the difference between 9 and 7, that is a 2, because they're opposite signs, and my 9 is going to be my positive number. So it factors into x plus 9, pardon me, and x minus 7. Using my zero factor property, I'm going to break those apart and each equal to 0. For the first one, subtract 9, and then therefore x equals negative 9. For the second one, I'm going to add 7 to both sides, x equals 7. So here are the possibilities of my odd integers. The first possibility is a negative 9. So the correlating number that goes with that, when x is negative 9, x plus 2 equals negative 7. And just to double check, negative 9 times negative 7 does equal 63. When x is the positive 7, x plus 2 is going to be 9. 7 times 9 is 63. Let's consider having two numbers and they add up to a particular amount, but I don't know what those two numbers are. For example, if I have two numbers and they add up to 50, I don't know what the numbers are. I'm just going to call one of them x. From knowing x, I can figure out what the other one is. It's 50 minus x. So if I add the two numbers, x plus 50 minus x, that's going to be x plus 50 minus x. The x's cancel out and I'm left with 50. See how that works? Likewise, if we have two numbers that have the sum of 100, one of them is y, the other one must be 100 minus y. You'll see a pattern coming up here. If two numbers have the sum of 10, and I'm calling one of them a, then the other one must be 10 minus a. Likewise, if they add up to 12, and I'm calling one of my numbers b, then my other number is 12 minus b. Now, knowing that kind of pattern, let's use it. The sum of two numbers is 13. Their product is 40. Let's find the numbers. Well, if I know they add up to 13, I'm going to call one of them x, and one of them 13 minus x. Okay. So they sum to 13. One is x, one is 13 minus x. Now the product of the two numbers is 40. So now I'm going to multiply them together, distribute the x, so I get 13x minus x squared equals 40. Move everything to one side. Now, I don't like the x squareds being negative, So this time around, I'm going to move everything to the right-hand side. I don't mind if x's are negative. I don't even mind if the constant's negative. To factor it, it's just easier if the x squareds are positive. So I'm going to move the 13x and the x squared over to the right-hand side. So minus 13x plus x squared, minus 13x plus x squared to both sides. I'm left with 0 equals 40 minus 13x plus x squared. I could rewrite this in descending order, but I'm going to go ahead and just factor it. So x squared will be x and x, two numbers that multiply to 40 but add to negative 13. My only options are negative 5 and negative 80. Or negative 8. So negative 5 times negative 8 is 40. You add them together. Minus 5 minus 8 is negative 13. Set both of them using our zero factor property. Set them both to 0. So my options are x will equal 5 or x will equal 8. Now these are two different solutions. The first solution is where x equals 5, therefore 13 minus 5 is 8. My second solution is when x is 8, 13 minus 8 is 5. There are two different solutions here. Granted, in multiplication and addition, order doesn't matter, but indeed there are two different solutions to this one problem, 5 and 8, and 8 and 5. Let's consider how we can use this in a geometry problem. The length of a rectangle is 3 more than twice the width. The area is 44 square inches. Let's find its dimensions. So I know an area of a rectangle is length times the width, and in our case it equals 44 inches squared. I don't know what the width is, but the length is in regards to the width. So I can say W, the width, equals x, and the length equals twice the width and 3 more. So 2x plus 3. Area is multiplication. So length is 3 more than twice the width. That's the 2x plus 3. Our W, our width is unknown, so that's an x. So I get 2x plus 3 all multiplied by x equals the 44. I'm not going to worry about the units quite yet. Distribute the x to get 2x squared plus 3x equals 44. We need it to be equal to 0, so we can solve for this. So we're going to move the 44 over, leaving us with 2x squared plus 3x minus 44 equals 0. There is not a greatest common factor, so I am just going to factor it and use trial and error. So I got to figure out the 44. I have my option of 11 and 4, 22 and 2, 44 and 1. The only one that makes sense is 11 and 4. So 2 times 4 will get me 8. 11, the difference between 11 and 8 is 3, but I need my 3 positive, so the 11 has got to be positive. That's how I figure out the negatives and the positives. Let's set both of them equal to 0. And I get 2x plus 11 equals 0. My solution here is negative 11 halves. X minus 4 equals 0. X is going to be 4. And we need to stop and think about this and figure out if these solutions are valid for the problem that I'm working with. Mathematically, they are valid. These are valid solutions to a mathematical problem. But do the answers to the solutions make sense to the problem that I'm solving for? 1. Lengths are never negative. So this negative makes absolutely no sense for the problem, although mathematically correct. It doesn't make sense to the problem. Therefore, my only solution I have for this is the length is 4 inches. Because of that, we now know that the length is 2 times 4 plus 3 8 plus 3, it's 11 inches, and the width, which was our unknown, is our 4 inches. So you do need to look at your solutions. Even though they're mathematically correct, you do need to make sure that your solutions make sense for the problem that you are applying the math to. And in this case, we can rule out one of our solutions because negatives are not a length measurement. Let's try another example. So the numerical value of the area of a square is twice its perimeter. What is the length of its side? So here I have all my information I know about a square. My area is the side squared, and my perimeter is 4 times s. For this problem, my area will equal the standard equation side squared, and it equals twice the perimeter. So if my perimeter is 4s, my area also equals 8s. Well, if I know it equals s squared and I know it equals 8s, I can set those two equal to each other and solve for s. So I have s squared equals 8s. Let's move the 8s over to the side so we can set it to 0. So s squared minus 8x equals 0. Let's factor it. S times s minus 8 equals 0. We're going to break those apart, set them each to 0, and see what our solutions might be. So first, s can equal 0, or s can equal s minus 8 equals 0, which is s equals 8. Again, we're working with lengths. So a length of 0 doesn't really make sense. Otherwise, I don't have a box. It has no length, has no width, or no side and no side. So the 8 makes sense. So the length of its side is going to be 8. Right? And if we want to check it, we can see that the perimeter is 4 times 8, which is 32. The area is 8 squared, which is 64. And it said the area was twice as much as the perimeter. 64 is twice as much as 32. We have a new property at our disposal. It's called the Pythagorean Theorem. And it says this is specifically for any right triangle. That means that the one angle is 90 degrees. The square of the longer side, which is called the hypotenuse, is equal to the sum of the squares of the other two sides, and we call those legs. So for example, if our triangle was labeled A, B, and C, then what the Pythagorean theorem states is that C squared equals A squared plus B squared. But this is very particular to a right triangle. So let's try it. 3 sides of a right triangle are 3 consecutive integers. Find the lengths of the 3 sides. So I'm going to let x equal the first integer, the shortest side. The next one will be x plus 1. That's the next consecutive integer. And then the final consecutive integer is x plus 2, which is the longest side, the hypotenuse. Using our Pythagorean theorem, a squared plus b squared equals c squared, I'm going to plug in x for a, x plus 1 for b, and x plus 2 for c. I get x squared plus x plus 1 quantity squared equals x plus 2 quantity squared. I'm going to FOIL all that out and add like terms. So after we FOIL it, after we distribute, do everything that we need to do for the multiplication part, we get x squared plus 2x plus 1 equals x squared plus 4x plus 4. I'm going to combine like terms as best as I can. I have a couple of x squareds I can add, combine. Then I'm going to move everything on the right-hand side to the left-hand side, leaving me with x squared minus 2x minus 3. Let's factor, giving me x minus 3 and x plus 1, setting them both to 0 and solving. Since length is not negative, then it can't be x plus 1 equals 0, which is x equals negative 1. But it can be 3. So my first number is 3, my second number is 4, and my third number is 5. So that's it for this part. Let's continue on to the next part.